Tonight, imagine the most powerful engine in our solar system doing something it has never promised us it won't do, going completely quiet. No solar flares, no eruptions, no storms, no violent ribbons of plasma snapping through space like cosmic whips, just silence. The sun still shines, still looks normal from Earth, still rises and sets like nothing happened. And that's exactly why this scenario is terrifying, because the real danger isn't always what you can see, it's what stops happening behind the light. For decades, we've been trained to fear solar storms, the kind that slam into Earth's magnetic field, paint the skies with auroras, and threaten satellites and power grids. But what if the opposite happened? What if the sun went calm for a full week, like a giant heart that suddenly refuses to beat harder, no matter what the body needs? At first, most people wouldn't notice. Your morning would begin the same way. Phones would light up, cars would start, the news would still argue about the usual things. And yet, above your head, in the invisible ocean of space, a chain reaction would begin. Not loud, not explosive, but unsettlingly quiet, like the moment a city goes silent right before a blackout. Because the sun's activity isn't just extra drama in space, it's part of the system that keeps our planet stable, protected, and predictable. That protection has a name: space weather. It sounds harmless, almost poetic, but it's a living, shifting shield of magnetic pressure and charged particles that constantly interacts with Earth's own magnetic field. When the sun is active, it pushes, it squeezes, it stirs the space around us like wind across a sea. When it goes quiet, the entire pressure balance changes. The solar wind thins. The magnetic bubble around Earth, our magnetosphere, stretches and relaxes in strange ways. And in that calm, a new enemy becomes louder: deep space itself. Cosmic radiation, high-energy particles from distant supernovae, from violent galaxies, from places so far away that the light we see today began traveling before humans built cities. Normally, the sun's wind and magnetic field help shape the boundary that filters some of that chaos. But if the sun's breathing slows down too much, Earth's defenses don't simply become stronger, they become different, and sometimes different is worse. Now, here's where the story turns from cosmic mystery into real-life consequences. Because the first cracks wouldn't appear in the sky, they'd appear on screens. Satellites would be the earliest witnesses, not because the sun is attacking them, but because the quiet changes the environment they fly through. The upper atmosphere, which normally swells and shrinks based on solar energy, begins to cool and contract. That sounds like a good thing, right? Less drag, smoother orbits. But here's the twist. Less drag means space junk stays up longer. Dead satellites, broken fragments, discarded rocket parts, everything that would normally slow down and fall back toward Earth now lingers, circling like invisible shrapnel in a growing graveyard. The sky above us becomes more crowded, more dangerous, more unpredictable, and the collision risk climbs quietly with every hour of silence. And collisions in orbit don't stay local. One crash can create thousands of new fragments, which can crash into more satellites, which can create even more fragments. A nightmare chain reaction called a cascade, a domino effect in space that can turn Earth's orbit into a minefield. And the scariest part? People on the ground still think it's just another week. But then something else begins to happen. Small glitches that feel random, harmless, easy to ignore. GPS drift, navigation errors. Not full collapse at first, just weirdness. A delivery driver ends up on the wrong street. A ship's route slightly misaligns. A plane's systems compensate and correct, but pilots notice tiny anomalies. Your map app hesitates. Your location jumps. It feels like a software bug. But it isn't software. It's physics. Because GPS is not just satellites, it's time. Atomic clocks in orbit sending signals so precise that a tiny delay can shift your position by meters, then tens of meters, then more. And those signals travel through Earth's upper atmosphere, through layers that respond to solar conditions. When the sun goes quiet, the ionosphere, the charged layer that bends and distorts radio signals, changes behavior. Not necessarily worse in a dramatic way, but unpredictable. And unpredictability is poison for a world built on precision. Financial markets use timing signals, power grids use synchronization, communication networks depend on stable propagation. Even modern farming uses GPS for precision planting. Quiet sun, loud consequences. Now imagine this: the auroras begin to fade. For some, that would be beautiful. No geomagnetic storms, no scary warnings. But for scientists, the disappearance of auroras is like a heartbeat monitor going flat. It's a sign that the sun isn't feeding the magnetosphere the way it normally does. It's a sign that the connection between the Earth and the sun is weakening in a way we don't fully control. And while people celebrate calm skies, the real watchers, the ones with instruments pointed at the sun, start to panic because a quiet sun is not always a safe sun. It can be a sun storing energy. It can be a sun resetting. It can be a sun preparing a snapback so violent that when it returns, it doesn't return gently. History gives us hints. There have been periods of low solar activity, like the Maunder minimum, when sunspots nearly vanished for decades, and Earth experienced colder conditions during parts of that era. Scientists still debate how much the sun contributed compared to volcanoes and ocean cycles, but the lesson is simple. When the sun changes, Earth changes, and our modern civilization has never faced a truly abnormal solar pattern with billions of people relying on fragile technology at every second. Now the week continues. Day 2, Day 3, Day 4. The silence becomes a global conversation. News anchors use phrases like unusual solar minimum, rare calm period, unexpected quiet. Social media turns it into memes at first, people posting jokes like, sun took a vacation, solar burnout, the sun is on airplane mode. But then the mood shifts, because the effects stop being funny. Radio communication starts acting strange in certain regions, not fully dead, but inconsistent. Some long-range signals travel farther than expected, others fade. Military systems quietly run extra checks. Aviation authorities monitor satellites like hawks, and somewhere above Earth, the International Space Station becomes a symbol of vulnerability, because astronauts are exposed to more radiation than we are, and if the sun's protective influence weakens, their risk increases. They're not in immediate danger in a week-long scenario, but the margin of safety shrinks, and that's what makes it terrifying. A quiet sun doesn't scream, it whispers, and the whisper is, you are not as protected as you think. Meanwhile, Earth's atmosphere responds like a living organism. The thermosphere cools.
The density changes. Orbits shift. Some satellites gain a little altitude stability, others behave oddly. Space traffic managers begin calculating new risk maps. It's invisible to you, but it's happening. And then comes the moment the public finally feels it in a way that can't be dismissed. Communications. Not total outage, something more unsettling. Patchy failure, intermittent disruptions, the kind that make people angry because they can't blame a single cause. Streaming buffers, calls drop. Emergency services still work, but the network load becomes unstable. The world becomes irritated, anxious, and then suspicious. Conspiracy theories erupt like wildfires. Some claim governments are hiding the real reason. Others say it's a sign of apocalypse. Some say it's aliens. Some say it's a simulation glitch. Because humans hate silence when we don't understand it. We can accept storms. We can accept disasters. But quiet feels like a trap. And the deeper truth is silence can be the most dangerous phase of any system, because it's when you stop receiving warnings. Solar storms, at least, are loud enough to alert us. A quiet sun removes the noise and removes the signals we've learned to read. But now, let's go even deeper, because there's a more chilling possibility, one that turns this from space science into civilization's stress test. Our planet is wrapped in magnetic fields that interact with the sun like two dancers locked in an eternal motion. If the sun's activity drops too low, the shape and behavior of Earth's magnetic shield changes, and the radiation environment shifts. That radiation doesn't just affect astronauts and satellites, it affects the upper atmosphere chemistry, it affects ozone dynamics, it affects how energy moves through layers of air that we don't think about, but that quietly decide what life below experiences. In just a week, you won't see Earth freeze, you won't see oceans stop, but you might see small, measurable anomalies, weather patterns nudging, jet streams shifting slightly, high-altitude temperatures behaving differently. Tiny changes, yes, but tiny changes in a complex system are like a small crack in a dam. Not catastrophic today, but proof that the structure is under forces you didn't plan for. Now imagine day 6. The world is watching. Space agencies hold briefings. Scientists speak carefully, choosing words that won't cause panic. They remind people the sun is still shining, Earth is still safe, life continues. But behind the calm language, there's a fear they won't say out loud. What if this silence is not the end, but the inhale before a scream? Because the sun is a magnetic machine, and magnetic machines don't stay still. They twist, they store energy, they release it. If a week of silence ends suddenly, the return could be violent. Not guaranteed, but possible. A sudden reawakening could unleash a major solar flare or a coronal mass ejection, the kind that hits Earth like a hammer. And if that happens after days of altered space conditions, the impact could be unpredictable. It could catch satellites in the wrong configuration, power grids in the wrong load state, communication systems in the wrong mode. The world would go from nothing is happening to everything is happening with no emotional preparation. And that's how real disasters hit, not with a warning siren, but with normal life continuing right up until the moment it doesn't. Now day 7 arrives, and the sun is still quiet. At this point, the silence itself becomes a psychological weapon. People look at the sky differently, not because it looks strange, but because it looks too normal. That's the horror. The sun is still golden, still warm, still bright, still the same circle that humans have worshipped, feared, and depended on since the first sunrise we ever understood. And yet now we know something unsettling. The sun can change without asking us. It can shift its behavior while we're arguing online, while we're working, while we're sleeping. And if it can row quiet for a week, it can do other things too. The week ends in one of two ways. Either the sun gradually returns to its usual rhythm and the world breathes again, laughing nervously, turning it into a story for documentaries and school textbooks, or it snaps back violently, reminding us why solar storms were feared in the first place. But even in the calm ending, the real damage remains. Not broken buildings, not shattered roads, but shattered confidence. Because we would realize something that modern society hates admitting. We don't control the biggest system we rely on. Our entire civilization is built under a star we cannot negotiate with. We can predict it sometimes, we can study it, we can prepare, but we cannot command it. And in that realization, HMD Origins finds the real mystery. The sun doesn't have to explode to destroy our comfort. It only has to become unfamiliar. It only has to behave in a way our fragile technology wasn't optimized for. A week of silence would expose how much of our world depends on invisible forces we rarely respect. The satellites above you, the magnetic shield around you, the radiation storms beyond you, the fragile layer of atmosphere protecting you, and the star that powers it all, not as a gentle lamp in the sky, but as a living engine of chaos and balance. So the next time you see a calm sunrise, remember this: the sun's loudest threat isn't always a storm. Sometimes the most terrifying message the universe can send is a simple one: silence. And if you stayed till the end, here's the final question, the one that should keep you awake. If the sun can go quiet for a week and we barely notice until systems start trembling, how many other cosmic switches exist above our heads right now, waiting to flip, while we live our lives thinking the sky is permanent? And that question, how many cosmic switches exist above our heads right now, waiting to flip, is where the real HMD origin story truly begins. Because the sun going quiet for a week isn't just a cool science scenario. It's a mirror held up to our civilization, exposing how modern life is built on invisible agreements we never signed. Agreements between Earth's atmosphere, magnetic field, and a star 150 million kilometers away that doesn't care if our phones work or our cities stay lit. And once you understand that, you realize the scariest part isn't the silence itself, it's what the silence allows us to hear for the first time. In a normal week, space is loud in its own way. Streams of particles, electromagnetic turbulence, constant subtle pressure against Earth's protective bubble. That background noise is so normal that we mistake it for nothing. But in a quiet week, the noise drops, and suddenly we start noticing the things we were never supposed to notice. Scientists would describe it as a shift in the heliosphere's dynamics, the great magnetic cocoon carved out by the sun that stretches far beyond Pluto, acting like a boundary wall between us and the raw, chaotic interstellar environment. You could think of it like a giant shield bubble. When the sun is active, that bubble is strong, inflated, and pushing outward, keeping some of the harshest cosmic radiation at bay. But when the sun goes quiet, the bubble weakens, contracts, and changes shape, like a lung that isn't breathing deeply enough. Now, here's the part most people never realize. Earth is not just orbiting the sun. Earth is orbiting inside a living magnetic ecosystem. We are passengers inside a protective storm system that is always moving. So when the sun goes quiet, it's not like a machine shutting down. It's more like the planet's entire protective environment becomes unfamiliar. And unfamiliar environments don't have to be immediately deadly to be dangerous. They only need to be unpredictable. Because predictability is what modern infrastructure feeds on. Predictability is what keeps planes aligned, keeps global networks synchronized, keeps satellites stable, keeps shipping routes efficient, keeps emergency response systems reliable, keeps financial systems timed down to fractions of a second. And the moment predictability fades, civilization doesn't collapse instantly. It begins to misbehave, like a body losing coordination before it loses consciousness. That's what a quiet sun week would feel like. Not apocalypse, but a slow global misalignment, a subtle drifting of systems that were designed to operate under normal space weather conditions. It's like the universe changed the rules by 1 degree, and suddenly everything we built starts wobbling. Now, the first major change that would quietly accelerate during the week is something you can't see from the ground: the reshaping of Earth's upper atmosphere. The sun's ultraviolet and X-ray radiation constantly energize the thermosphere and ionosphere, making them expand, contract, and behave like a living layer of electrically charged air. When solar energy drops, the upper atmosphere cools and shrinks. That might sound harmless, like the sky simply relaxing, but the consequences are technical and immediate. Satellite orbits depend on atmospheric drag. When the atmosphere shrinks, drag decreases, and satellites that would normally slow down and re-enter the atmosphere stay up longer. That means broken satellites and debris remain in orbit for years longer than expected. It also means active satellites experience slightly different orbital behavior than planned. And when you have tens of thousands of tracked objects and countless untracked fragments moving at bullet speed around Earth, slightly different becomes a serious problem. Space agencies would begin issuing more collision avoidance maneuvers. Operators would burn fuel to dodge debris. Some satellites would run out of fuel earlier than expected. And once a satellite runs out of fuel, it can't dodge anymore. It becomes a silent target, a floating hazard, a ticking bomb. The quiet sun doesn't destroy satellites directly. It creates the conditions for satellites to destroy each other. And that is the kind of disaster humanity is uniquely vulnerable to. A disaster we cause ourselves because the environment shifted just enough to make our orbit unstable. This is where the nightmare becomes layered, because the world doesn't realize it's watching the beginning of a long-term crisis. In the short term, everything still works, mostly. But in the long term, one chain reaction collision could multiply debris so fast that certain orbital regions become too dangerous to use, cutting off communications, weather monitoring, Earth observation, and navigation infrastructure. Imagine a future where launching new satellites becomes too risky. Imagine the world trying to operate without stable GPS, without global weather prediction, without modern surveillance of storms and disasters. Not because Earth was destroyed, but because space became too crowded with sharp metal ghosts. And the terrifying part is that this could begin during a quiet sun week without the public noticing at all. The sky looks the same, the stars still sparkle, but above you, the orbit you depend on becomes a battlefield of physics. Now, let's talk about the second layer of the quiet sun week, the layer that hits civilization where it hurts the most: timing. Most people think GPS is about location. It's not. It's about time. Your phone knows where it is because it measures how long signals take to arrive from multiple satellites. That requires timing so precise that even tiny changes in signal behavior can create errors. And those signals pass through the ionosphere, a charged layer that bends and delays radio waves. When the sun goes quiet, the ionosphere changes density, structure, and behavior. Sometimes it becomes calmer, sometimes it becomes uneven, sometimes it becomes more layered, and the result is not better, it's different. Different means your GPS correction models built on typical solar conditions can become less accurate. This doesn't mean everyone gets lost instantly. It means small errors start creeping into systems that require perfection. Precision agriculture loses efficiency. Construction surveys become slightly off. Shipping logistics drift. Military navigation systems increase redundancy. Air traffic control relies heavily on backups. Financial networks, which depend on precise time synchronization, begin to operate under tighter error margins. And the moment predictability fades, civilization doesn't collapse instantly. It begins to misbehave, like a body losing coordination before it loses consciousness. That's what a quiet sun week would feel like. Not apocalypse, but a slow global misalignment, a subtle drifting of systems that were designed to operate under normal space weather conditions. It's like the universe changed the rules by 1 degree, and suddenly everything we built starts wobbling. Now, the first major change that would quietly accelerate during the week is something you can't see from the ground: the reshaping of Earth's upper atmosphere. The sun's ultraviolet and X-ray radiation constantly energize the thermosphere and ionosphere, making them expand, contract, and behave like a living layer of electrically charged air. When solar energy drops, the upper atmosphere cools and shrinks. That might sound harmless, like the sky simply relaxing, but the consequences are technical and immediate. Satellite orbits depend on atmospheric drag. When the atmosphere shrinks, drag decreases, and satellites that would normally slow down and re-enter the atmosphere stay up longer. That means broken satellites and debris remain in orbit for years longer than expected. It also means active satellites experience slightly different orbital behavior than planned. And when you have tens of thousands of tracked objects and countless untracked fragments moving at bullet speed around Earth, slightly different becomes a serious problem. Space agencies would begin issuing more collision avoidance maneuvers. Operators would burn fuel to dodge debris. Some satellites would run out of fuel earlier than expected. And once a satellite runs out of fuel, it can't dodge anymore. It becomes a silent target, a floating hazard, a ticking bomb. The quiet sun doesn't destroy satellites directly. It creates the conditions for satellites to destroy each other. And that is the kind of disaster humanity is uniquely vulnerable to. A disaster we cause ourselves because the environment shifted just enough to make our orbit unstable. This is where the nightmare becomes layered, because the world doesn't realize it's watching the beginning of a long-term crisis. In the short term, everything still works, mostly. But in the long term, one chain reaction collision could multiply debris so fast that certain orbital regions become too dangerous to use, cutting off communications, weather monitoring, Earth observation, and navigation infrastructure.
Imagine a future where launching new satellites becomes too risky. Imagine the world trying to operate without stable GPS, without global weather prediction, without modern surveillance of storms and disasters, not because Earth was destroyed, but because space became too crowded with sharp metal ghosts. And the terrifying part is that this could begin during a quiet sun week without the public noticing at all. The sky looks the same, the stars still sparkle, but above you, the orbit you depend on becomes a battlefield of physics. Now, let's talk about the second layer of the quiet sun week, the layer that hits civilization where it hurts the most: timing. Most people think GPS is about location. It's not. It's about time. Your phone knows where it is because it measures how long signals take to arrive from multiple satellites. That requires timing so precise that even tiny changes in signal behavior can create errors. And those signals pass through the ionosphere, a charged layer that bends and delays radio waves. When the sun goes quiet, the ionosphere changes density, structure, and behavior. Sometimes it becomes calmer, sometimes it becomes uneven, sometimes it becomes more layered. And the result is not better, it's different. Different means your GPS correction models built on typical solar conditions.
A satellite loses attitude control for a few seconds. Another experiences a sensor glitch. A third has a power subsystem hiccup. Engineers notice patterns. They start to suspect the quiet sun is changing the radiation environment in a way that increases system stress. And if you run a world where satellites are the nervous system of civilization, stressing that nervous system is like stressing the brain of a living organism. The body might still move, but coordination begins to fail. Now, let's move to something even deeper, something that feels almost impossible but is scientifically real. Earth's climate and weather patterns can be influenced indirectly by solar variability. Not because the sun turns off its heat, but because subtle changes in solar radiation and atmospheric chemistry can ripple into larger systems. During a quiet week, the total solar energy reaching Earth doesn't drop enough to freeze the planet, but the upper atmosphere cooling can affect circulation patterns. It can slightly alter how energy is distributed. These effects are small and complex, but complex systems are sensitive. It's like nudging a spinning top. It doesn't fall instantly, but its wobble changes. Weather forecasting models might start showing slight deviations. Long-range patterns might shift. Again, not a Hollywood disaster, but a reminder that Earth is a coupled system. The sun is not a lamp, it is a driver. And when the driver changes behavior, the car doesn't explode, it begins to drift. Now imagine the public response as the week drags on. The quiet becomes suspicious. People stop trusting it's normal. They start looking for meaning, and meaning is where humans become dangerous, because we don't just observe reality, we rewrite it into stories. Some groups would claim it's a sign of the end times. Others would claim it's proof of secret weapons. Others would claim it's proof we live in a simulation and the simulation is lagging. And then comes the most realistic, most terrifying reaction of all: opportunism. Scammers would appear instantly. Fake solar blackout survival kits, fake solar silence emergency supplies, fake NASA-leaked documents. Fear becomes a marketplace. And while people argue online, infrastructure teams quietly work overtime to ensure stability. Because even if nothing catastrophic happens, a week of unusual solar conditions is enough to reveal weak points. Power grids might be safer without geomagnetic storms, yes, but they still rely on timing, communication, and stable satellite services. Emergency response relies on connectivity, hospitals rely on networks, transportation relies on synchronization, and the quiet sun week would become a reminder that modern life is a delicate orchestra, beautiful, efficient, powerful, but fragile when the conductor changes tempo. Now we reach the part of the story where the quiet becomes the most dangerous thing it can be: a mask. Because while the sun is quiet, people stop expecting danger. They stop looking for threats from above. They relax. And that is when the universe loves to strike. Not because the universe has intention, but because randomness always hits hardest when you're not prepared. And here's the twist. A quiet sun week could actually increase the shock of what comes next, because solar magnetic systems don't stay calm forever. The sun's surface is a battlefield of magnetic fields, twisting, tangling, and reconnecting. Solar flares happen when those fields snap and release energy. Coronal mass ejections happen when giant loops of plasma detach and blast into space. A quiet week could be a period where energy is stored, not released, like a spring being compressed. And if that spring releases suddenly, the event could be stronger than expected. The return of solar activity could be violent, not gentle. Imagine the world watching a silent sun, and then suddenly the sun erupts with a flare so bright it saturates sensors. A coronal mass ejection launches directly toward Earth. Space agencies issue warnings. News channels panic. People who spent a week laughing about sun vacation suddenly realized they were watching the calm before the strike. And if that storm hits, the consequences could be far worse than a normal storm, because the world has been operating under altered conditions. Satellites might be in vulnerable modes, debris fields might be more chaotic, communication networks might already be stressed. The storm becomes the final push that breaks systems already wobbling. Now imagine the visuals. The auroras return, but not gently. They explode across the skies at latitudes that rarely see them. People record it on phones, calling it beautiful. But behind the beauty, power grid operators hold their breath. Transformers heat up. Currents induced in long power lines threaten equipment. Some regions might experience outages. Satellites might temporarily fail. Radio blackouts could occur. Aviation routes shift, and for a brief moment, the modern world tastes what it means to be dependent on a star. But even if the sun doesn't strike back violently, the quiet week leaves a permanent scar on human psychology, the realization that we are not in control. We are not the masters of the system. We are not the owners of stability. We are tenants living under cosmic conditions that can change without warning. That is the H.M.D. Origins truth. And now we go even deeper, because the quiet sun week opens a door to an even bigger mystery, one that scientists quietly fear and rarely discuss in public. What if the sun isn't just quiet, but entering a deeper, longer phase of low activity? What if this week is not a glitch, but a preview? The sun operates in cycles, roughly 11 years, waxing and waning in sunspots and flares, but history shows the sun can enter extended minima, periods where activity drops dramatically for years or decades. If humanity entered such a phase, the consequences would not be immediate apocalypse, but slow transformation. Climate patterns could shift slightly over decades. Satellite environments would change. Cosmic ray exposure would increase. Space exploration would become riskier. And the psychological relationship between humans and the sky would change forever. People would stop thinking of the sun as a constant and start thinking of it as a variable. And variables make humans anxious because we build our lives around constants. Now let's bring the story down to ground level, because the most chilling part of this scenario is how normal life would look while the invisible systems strain. You'd still go to work, you'd still eat dinner, you'd still scroll, you'd still sleep. The sun would still shine, and yet the world would be quietly accumulating risk. Risk in orbit, risk in timing, risk in radiation, risk in infrastructure dependency. It's like a crack forming under the foundation of a skyscraper while the lights inside still glow. People inside laugh, unaware. Engineers outside stare at the stress lines, knowing that a structure doesn't collapse when the crack appears. It collapses when the crack meets pressure, and pressure always comes. It always comes in the form of a storm, a failure, a mistake, a collision, a cascade. and the quiet sun week would be remembered not as the week the sun stopped, but as the week humanity realized how fragile its normal truly is. Because normal isn't guaranteed. Normal is borrowed. Normal is a temporary agreement between physics and luck, and that agreement can be rewritten without warning. So when the week ends and the solar activity returns and the auroras flicker back to life and the news cycle moves on, the real question remains hanging in the air like a shadow you can't shake. If the sun can go quiet and bend the invisible systems that hold our world together, what happens when it doesn't go quiet but goes extreme? What happens when the sun doesn't whisper but screams? And what happens when one day humanity looks up and realizes that the sky was never a ceiling, it was a living machine, and we have been living inside of it this entire time? Because the sun isn't just the source of light, it's the source of stability, and stability is the rarest luxury in the universe. And if you're still watching right now, then you already feel it, that creeping realization that the quiet wasn't peace, it was a warning. A warning that the universe doesn't always announce its biggest changes with explosions. Sometimes it announces them by removing the noise, by making the familiar feel strange, by letting the world continue as normal while the foundations shift. And that is why a week of sun silence might be one of the most terrifying what-if scenarios ever. Not because it would end the world in 7 days, but because it would prove the world can begin to break without anyone noticing.